10.7b, quadratic formula, make equation equal 0. In this video, you need to remember that before you use the quadratic formula, you must make the equation look a very specific way. In this case, the equation must equal 0, and be in order. What I mean when I say in order is that the exponents must be in descending order. So the equation should look like this: ax squared plus bx plus c equals 0. Notice that my exponents are indeed in descending order. 2 as an exponent, 1, even though we don't write it, it's understood to be there, and x to the 0 is equal to 1. So we don't write that either, but it is understood to be there. Let's take a look at example 1. We have 2x squared, and we need to get 15 and negative 7x on the same side of the equal sign. We do this by adding the opposite. We will subtract 15 from both sides. Now we have 2x squared minus 15 equals negative 7x, and then we'll add 7x to both sides. And that will give us 2x squared plus 7x minus 15 is equal to 0. Notice that I conveniently placed my terms in order of descending exponents. This is very important because your next step will be to assign a, b, and c, as we saw in the previous video. So a is equal to 2, b is equal to 7, and c is equal to negative 15. Remember, our equation, or our formula for the quadratic equation, is negative b plus or minus the square root of b squared minus 4 times ac all over 2a. If you don't have this memorized, you should. So memorize it. Here we go. X is equal to 7, negative 7, plus or minus the square root of b squared, 7 squared, minus 4 times a, which is 2, and c, which is negative 15, all over 2 times 2. When I simplify this, I get negative 7 plus or minus the square root of 49. And once again, I have a negative and a negative, which will make a positive because I'm multiplying. So I'm going to have a positive. 4 times 2 is 8, times 15 is 120. All over 2 times 2, which is 4. So when I simplify this further, I get 169 in the square root over 4. I'm going to simplify this further because I know that 169 is equal to 13 squared. That's what's in there. So I can rewrite this as negative 7 plus or minus 13 all over 4. This is going to give me two distinct solutions for x. X is going to equal negative 7 plus 13 over 4, and x is going to equal negative 7 minus 13 over 4. So my solution for x for the first solution is 6/4, which reduces to 3/2. And for my other solution, I'm going to get x equal to negative 20 over 4, which is negative 5. Now let's look at example 2. In this case, we only have one term sitting all by itself on the right side of the equation, and we just need to set this equation equal to 0. So we're going to go ahead and subtract 7 from both sides, and that's going to give us 3x squared plus 5x minus 5 equals 0. So I've got a is equal to 3, b is equal to 5, and c is equal to negative 5. Now I can plug in those values for a, b, and c in the quadratic formula, and I will get the following. X is equal to negative 5 plus or minus the square root of b squared minus 4 times 3 times negative 5 all over 2 times 3. Just as a side note, the quadratic formula can be sung to Pop Goes the Weasel, but I'm not going to do it for you in this video. Let's simplify that square root. 5 times 5 is 25. 4 times 3 is 12 times 5 is 60. And it's a positive 60 because we've got a negative times a negative, which is a positive. All over 2 times 3 is 6. So the sum of 25 and 60 is 85 all over 6. And since our denominator is positive, we have found the solution. Because 85 is not a perfect square, we cannot simplify that radical further other than writing it as a decimal approximation on a calculator, which we don't want you to do. So there are two solutions here, but normally we just write them the way they are right now. We could also write it like this. But you don't have to. This is equally as good and one less step.